welcome to another WJEC A level physics question. This was from Unit 1 in May 2012. It was question 2 on that paper, and it's basically about superconductors and superconductivity, which nowadays is actually in Unit 2. The first part of the question simply asks us, what is a superconductor? Well, superconductors are materials that if you cool them below a certain temperature, which is mentioned in the next part of the question, those conductors basically lose all their resistance. And because this is only one mark, all we're really looking for is something like that. It's a material that has zero resistance. In the next part of the question, we're told that a metal conductor is placed in liquid helium, and it's noted that at a certain temperature, as the metal cools, its resistance changes suddenly, dropping rapidly to zero. What name is given to the temperature at which the sudden change occurs? Well, we can call it either the superconducting transition temperature, or we could call it the critical temperature. Either one of those is fine. On the next part of the question, we're asked to sketch a graph of resistance against temperature for that conductor, labelling any key features of your graph. So what we're going to have here, on the y-axis we're going to have resistance, on the x-axis we're going to have temperature, and I'm going to put the temperature in Kelvin, resistance in ohms. Now the reason I'm putting the temperature in Kelvin is that this critical temperature is very, very low. As it mentioned in the question, it's something like the temperature of liquid helium, very, very close to absolute zero. For the shape of the curve, all we want is a flat region somewhere down here, a steep, almost vertical line, and then a line in this region which the exam board are not generally worried about in terms of whether it's straight or curved. So this temperature is our critical transition temperature, so I'll label that as TC in the previous part of the question. If I put this scale in Celsius instead of Kelvin, it would be implying that the transition temperature was above 0 Celsius, and it's not. It's actually very close to absolute zero, so here we're making sure that we got the temperature labelled in Kelvin. And this region, that's the superconducting region. Next part of the question asks us what potential difference would be needed to maintain a current in the conductor when it's been immersed in liquid helium for some time. And the key word here is maintain. Because there's no resistance, there's nothing to slow down the electrons in the circuit. So once a current starts to flow, we don't actually need any potential difference at all to keep that current from flowing. And the last part of the question, conducting electrons in a superconductor do not cause a heating effect. Explain why conducting electrons do produce a heating effect in wires at room temperature. Well, the reason that we don't have collisions in we don't have a heating effect in a superconductor is because in a superconductor there are no collisions between free electrons and the ions that make up the crystal lattice. So in a normal conductor we do have collisions. So what we need to refer to in this answer is collisions between free electrons, or delocalized if you prefer, and ions, or the lattice if you like. And in these collisions there is a transfer of kinetic energy from the electrons to the ions. And in that transfer of kinetic energy in the collisions, this leads to the ions vibrating further and faster. Which is what we see as a rise in the temperature. So quite a short question there. Thank you very much for listening. Please remember to like and subscribe.